Chapter 2, Section 4, Deductive Reasoning. So we've already talked about inductive reasoning. Deductive reasoning, which is also referred to as logical reasoning, is the process of reasoning logically from given statements or facts and coming to a conclusion. So we're going to learn about a few laws here, and we're going to talk about it more in class, but we're going to start with the law of detachment. If a conditional is true and the hypothesis is true, that means that the conclusion must be true. So if the conditional is true, and there's the hypothesis in the beginning, the conclusion at the end, if the beginning is true, then the end must be true as well, which we know because when we had something true imply something true, that gave you an overall true. When we had something that was true imply something that was false, that meant that the overall statement was false. But when we had something that was false imply something that was true, it gave us a true. So what this is saying is, if the overall conditional is true and the first statement is true, the second part of the statement must be true as well. So let's say the given statement is, if a ray divides an angle into two congruent angles, then the ray is an angle bisector. So the hypothesis is a ray divides an angle into two congruent angles. The conclusion is the ray is an angle bisector. The next given says that ray RS divides angle ARB so that angle ARS is congruent to angle SRB. So if we think of this as a picture, we have angle ARS and ray RS is dividing angle ARB into two congruent parts. So, working this out using deductive reasoning, if a ray divides an angle into two congruent parts, then the ray is an angle bisector, so we have our hypothesis and our conclusion. It's telling us that ray RS divides it into two congruent parts, so it's telling us that the hypothesis is true. The second statement matches the hypothesis of the given conditional, so that's this second statement right here matches the hypothesis. So by the law of detachment, you can make a conclusion. You can make the conclusion that RS is an angle bisector. So it's kind of common sense. If the first part of a conditional statement is true, then the second part must be true as well. So if RS cuts the angle into two congruent parts, then RS must be an angle bisector. So let's try this second given. If two angles are adjacent, then they share a common vertex. So we have our hypothesis, two angles are adjacent, and our conclusion, they share a common vertex. The next given statement is angle 1 and angle 2 share a common vertex. So this is telling us two angles are congruent, they share a common vertex. Angle 1 and 2 share a common vertex. The information in the second statement about angle 1 and 2 does not tell you that the angles are adjacent. The second statement does not match the hypothesis of the given conditional. So this second statement isn't the hypothesis of the given conditional. So you can't use the law of detachment here. Angle 1 and 2 could be vertical angles, since vertical angles also share a common vertex. So they could be vertical or they could be adjacent. You can't make any conclusions from here. However, if this had said angle 1 and angle 2 are adjacent, then you could assume that they share a common vertex. The law of syllogism is the second law that we're going to be focusing on this section. It allows you to state a conclusion from two true conditional statements, when the conclusion of one statement is the hypothesis of the other. So if you're given, if a figure is a square, then the figure is a rectangle. And then you're given, if a figure is a rectangle, then the figure has four sides. Well, you'll notice that the figure is a rectangle is stated as the conclusion of the first statement and the hypothesis of the second statement. Therefore, the conclusion of the first statement is the hypothesis of the second statement, so you can use the law of syllogism to make your conclusion. So what you do is you take the hypothesis from the first statement and you attach it to the conclusion of the second statement. It's kind of like the transitive property. You take the first part and the last part. So basically, since A equals B and B equals C, then A has to equal C. This is similar to the law of syllogism. So let's look at the given example. It's asking what you can conclude from the given information and what your reasoning is. So if a river is more than 4,000 miles long, then it is longer than the Amazon. So this is the conclusion of the first statement. The next statement says the river is longer than the Amazon, then it is the longest river in the world. So using the law of syllogism, we can take the hypothesis from the first and attach it to the conclusion of the second, since they share a common simple statement as the conclusion of the first and the hypothesis of the second. So our conclusion, what we can conclude, is that if a river is more than 4,000 miles long, then it is the longest river in the world. Now the last and final statement says the Nile is 4,132 miles long. Well, we see that if it's more than 4,000 miles long, then it's the longest river in the world. So we have, this is a true conditional. The hypothesis is true. In this statement, it's basically repeating the hypothesis. This is more than 4,132 miles long is more than 4,000 miles long, which means the Nile is the longest river in the world. So first we used the law of syllogism for numbers 1 and 2. Then we used the law of detachment for our new conditional and number 3.